Hello everyone, welcome back to this channel. Let's continue our machine learning interview series. First question: what is dropout in the context of neural networks and why is it used? So you can say that dropout is a technique used to prevent overfitting. Now the related question may arise that what is overfitting? Do you know what is overfitting? Overfitting is when your model is performing extremely well during training but not during testing. That may happen due to many reasons, like maybe the model has not understood the generalized pattern. Instead, it has memorized all the point. So that's why it is unable to perform on the unseen data. So the outcome is overfitting. Now we must have some techniques to prevent overfitting, and dropout is one of them. Okay, so in one line you can say that dropout is a technique that is used in neural networks to prevent overfitting. Now if the interviewer asks you how it stops from overfitting, then you can say that it randomly drops out some neuron to zero. That is, output of some neuron is set to zero so that the next layer always doesn't get to see the complete layer. If it can see the complete layer every time, then what will happen? It will understand but these are the outcomes and it will try to memorize things. It's like if you get the question papers, if you try to memorize all the questions, then you will be able to perform well during your class test. But when you will give the main exam where have not seen the questions, there you will not be able to answer because you have not understood the pattern. Instead, you have memorized every data points. Okay, so you are performing good for the seen data, but when you have not seen the data, there you are unable to understand how to predict. So that is why what dropout does in a layer, some neurons, some randomly selected neurons are set to zero. So what happens? Maybe in the first epoch, you are taking 5 neurons out of 10 neurons. Okay, 50% you have set to zero. Let's say. So what is happening? You are getting output from 5 neurons. The next layer. And in the next epoch, the same layer is getting 5 more outputs, sorry, 5 different outputs from different neurons. Maybe not those 5 which were used earlier. Some other 5 neurons are giving outputs to the next layer. Okay, so you understand that input for any particular layer is getting different in every epoch, and that is selected completely randomly. How? By setting other neurons to zero. That's why the term is dropout. And here what happens? You cannot memorize the things because you cannot see them every time. So you have to understand. Okay, so that's why then overfitting may be reduced and your perform may well enough for training data as well as for testing data. So that is what is written here. You can read this. I will put this link to the description box. Okay. Now suppose interviewer asks you, can you tell me any other technique where we can use overfitting? Then you can say, yeah, there are many techniques, but you can also say about early stopping technique. What is early stopping? Early stopping is like machine will automatically detect where the loss is getting reduced, but the validation loss is not getting reduced. There it will stop the training and it will restore the best weights where the loss were minimum, both of the loss and the validation loss. When both of them are at the minimum scenario, that is the best weights. Okay, those are fetched and model stops training. That is known as early stopping. That is also a technique to reduce overfitting. Okay. Now the second question: compare the ReLU and sigmoid activation functions. There are many kind of activation functions. Maybe first tell me why activation functions are required. Activation functions are required to capture the non-linearity. What is non-linearity? Non-linearity means when your data sets cannot be separated by a single line. This is not linear. Maybe there is a curvature, like sigmoid function, there is a curve. Maybe there is that is a parabola. That is not a straight line. So in those scenario, we can say that the data is non-linear data. And to capture the non-linearity, you have to use any kind of activation functions. Okay. Now you know that every activation functions have different kind of advantages or disadvantages. So interviewer may ask you anything. So you have to tell what is the benefits of taking ReLU and when to use the sigmoid activation function. See, ReLU here the function is maximum of 0, comma x. It means that if it gets some negative values, then it will set it to 0. Okay. Negative values will not be passed on. ReLU will make them 0. So that's why it has some advantages as well as some disadvantages also. It may create a sparse matrix because it is making every negative points to 0. Advantage is that it is introducing non-linearity. Okay. And there is also a problem called dying ReLU problem that we will discuss in our next question. Okay, so this is what is ReLU function, and you have to use this ReLU activation function when? After you use the dense layer. Okay, now tell me about sigmoid function. Sigmoid function, this is the equation. Whatever you are getting the output, you have to pass it through this equation. Okay, so what will happen? The output will come into a range of 0 to 1. And when it is used, mainly it is used for binary classification problem. How? Because if the output is greater than 0.5, then it will belong to some positive class. If it is less than 0.5, then it will belong to some negative class. Okay. So the output will be into a range, and depending on where the value is, we can classify the output accordingly. That's why sigmoid function is used. Okay. Now suppose a tricky question. Suppose you have a binary classification problem. So which activation function will you use at the end of the neural network? Then you have to say sigmoid, because sigmoid will be able to classify them depending on whether the value is above 0.5 or below 0.5. Okay. But in the middle of the layer, you can use ReLU functions to capture the non-linearity. But sigmoid will help you to classify. Okay. Now, what is dying ReLU problem? The disadvantage of ReLU problem. What is dying ReLU? So, dying ReLU means suppose your output is negative most of the times. So, in that scenario, ReLU makes them zero. So, what is happening? Significant number of neurons are becoming inactive, becoming zero. They stop learning. So, it is ultimately dying, right? So, there, as it receives the negative inputs, the output will become zero. It will contribute nothing. It will not learn, and it loses its network capacity. That is what is known as dying ReLU. Now, how can we solve this problem? Can we solve? How can we solve? The solve is that don't make them zero for negative. Instead, give some small slope, some non-zero, some alpha value. Typically, it is 0.01. Okay? Or you can use parametric ReLU also. Parametric ReLU means there is a learnable slope. Leaky ReLU is a fixed slope, alpha 0.01. Typically 0.01, whatever it is, this is fixed. But you can give some learnable slope also, which learns, okay, for negative inputs. Just don't set them to zero because they will stop learning. Instead, you can use leaky ReLU or parametric ReLU. There are different other types also. Okay. So you understand what is dying ReLU and what are the solutions. Now our next question. What is bias variance trade-off and how does it affect? See, if your model is too simple, so what is happening, it cannot capture the underlying pattern because it is too simple. Maybe you have used smaller number of networks, smaller number of you need smaller number of layers. Maybe you are not using proper activation function. So what is happening, your model is too simple, it is not understanding what is the pattern. It's like you are not reading at all, so you are not learning anything, so you are actually underfitting. That is what is known as bias, when your model is underfitted. Okay. Exact one is variance. When you have memorized too much, when you have kind of revised, not revised, you have memorized everything. That is when it happens, it's overfitting. That time we can say that it is a high variance. Okay. Where I already told you that your loss is getting reduced, model is performing good in training, but the validation loss is getting increased. So your model is not performing well during testing. So there is a overfitting. That's when we can say that if the model has high variance. Okay. So it is working good for training data, but not for testing data. So what is the solution? If we make the model too simple, it becomes a bias problem. If we make the model too complex, too many learning layers, too many neurons, too many functions, so what is happening? You are remembering everything, you are memorizing everything. That's also a problem. So you have to take a midway between bias and between variance. That is what is known as bias variance trade-off. Okay. So it will reduce the total error. So it will use some techniques so that it doesn't go for bias. The model is not too simple, or the model is not too complex by some regularization method. Okay. Now, how does batch normalization improve the training of deep neural network? Do you know what is batch normalization? Why it is used? What are its benefits? Batch normalization. Sorry. So batch normalization helps to stabilize the training. It solves the internal covariate shift problem and it helps in faster convergence. Now the cross question, what is internal covariate shift? It is like when your data set looks different from training data to testing data. Suppose I give you an example. While training your data, your model has seen some smaller red apples. Okay, but the shape is apple. But while testing, your model is getting some bigger size green apples. So now the problem is that shape is apple, but there it was small red size, but now it's green big size. Now this model faces a problem due to size and color. So this problem is due to covariate shape. Okay. So what you have to do, you can solve this problem by using batch normalization. So what batch normalization does here, it normalizes the inputs to each layer. Whatever the output is from the previous layer, first it takes, then normalize, and then it passes into as an input to the next layer. They have a consistent distribution now, and covariate shift problem is done. So this normalization techniques helps improving in the performance and also speeds up the training. So now question is where it is used? Batch normalization. Batch normalization is used after the output but before the activation function. After the dense layer output but before the activation function. Okay. So before it passes the output to the activation function, it normalizes the scale, brings them into a single scale so that the shift is gets reduced. Okay. So we have covered all the questions for the day. If you have any related questions or if you want me to discuss something else, let me know in the comment section. Till then, bye. Happy learning.